right, today we are doing advanced factoring, and honestly, I think of these as puzzles. I think they're super fun. You have to try to figure out what pieces you're working with, and then go from there. I'm going to do a few of them with you just to make sure we have some examples on some different types. You have on Blend also a sheet that has the different factoring types, the different types of factoring. That kind of walk you through how each one works. So if you haven't read that yet, or you missed class or something, I would do that before you start watching these, because if you don't know the types, it's not possible to do. So the first thing is to try to see what kind of a thing it is, and I'll kind of walk through how this works. Like when I see this, oh, difference of two squares from algebra 1. It's just a weird difference of two squares. When I see this, I see, oh, it's something squared plus 3 times that something minus 10. This is a quadratic form. It's x is log of x minus 4, so that's what's being squared. That's your x that you're factoring. Here, it's 64 minus a cubed. This is a difference of 2 cubes because 64 is 4 cubed, and a cubed is a cubed. Here we've got just a quadratic with weird numbers here. I'm going to do a few of these. This one, when we see it, you should recognize it as the result of a binomial cubed. And the way we see that is it's p cubed, then p squared, p, no p's. Do you see how the p's go down by 1 each time? And the q's, it starts out with no q's, goes up by 1, goes up by 1, goes up by 1. And since it goes positive, negative, this is probably the difference of 2 cubes. So the question is, the difference of 2 cubes formula says it's a cubed minus 3. A goes down by 1, the power of a goes down by 1, the power of b starts going up, plus 3ab squared. Again, a goes down each time, b goes up. This is what let me know it was a difference of 2 cubes. So the question is, what is the a and what is the b? Well, a is very clearly p here. So it's p minus, well, what is the b that's you're doing here? It's, well, 8q cubed. What is the thing that's being cubed? It's 2q. 2q times 2q times 2q is 8q cubed. So this is p minus 2q cubed. And you can see it works for each one of these. 3 times, well, let's just ignore the a's because it's pretty obvious. It's p cubed, p squared, p, and then no p's. But let's look at the q's and the constants. We've got negative 3 times 2q is negative 6q. We've got positive 3 times 2q squared, which would be 4q squared. 3 times 4q squared is 12q squared. And last, we get the minus 8q squared. So this is a difference of 2. This is a binomial that's being cubed. Let's go with another one here. This one is fun because there's actually 2 completely correct ways to do this. You could recognize that this is the difference of 2 cubes, or you could recognize it's the difference of 2 squares. I want to show you both ways. You could think, hey, you know what? This is 1 minus y cubed squared. Because when you take a power to a power, the powers multiply. So this would be 1 minus y to the 6th. And 1 is 1 squared. So it's 1 squared minus y cubed squared. If we do it as difference of 2 squares, that would be 1 plus y cubed times 1 minus y cubed. That is difference of 2 squares factoring, right? But we are not done because this can still be factored more. This is the sum of 2 cubes. This is 1 cubed plus y cubed. The sum of 2 cubes is 1 plus y times 1 squared, which is 1, minus 1 times y, which is y, plus y squared, plus the last one squared. So you should know these formulas. That's what this breaks up into. This is the difference of 2 cubes. That breaks up into 1 minus y times 1 times y, which is, 1 squared, which is 1, 1 times y, which is y, plus y squared. Man, this is crazy, but this is what it broke up into. This is our factored form. There was another possible way we could have done this, though. What if instead of thinking this as 1 squared minus y cubed squared, what if we thought of this as 1 cubed, because 1 times 1 is 1, minus y squared cubed. Now it's the difference of 2 cubes. And so we could factor it like this. 1 minus y squared, that's the thing that's being cubed, times 1 squared is 1, plus 1 times y squared is y squared, plus y squared squared is y to the 4th. This is factored, and we can't factor this one more, at least you guys don't know how to, but we can factor this one more. So 1 minus y times 1 plus y times 1 plus y squared plus y to the 4th. These are both acceptable factorizations. If we were a little bit more advanced, we could kind of try to figure out clearly we've got 1 plus y times 1 minus y on both of them, okay? But why is this times this equal to this? They are equal, but we're not going to delve into that here. So if you got to either here or here, this would have both been full credit. On the back, let's look at some tricky ones. This is kind of like that log one. Something's being squared. Here's that something. And so what is that something? The cube root of x. There's two ways to think about this. One is you can do a substitution. Let a equal the cube root of x. This is if you really have trouble seeing it. Then this is the cube root of x squared. So it's a squared plus 7a minus 18, and you can factor it just like a regular quadratic. This is a, let's see, we need two things that multiply to make negative 18 that add to be 7, so it's plus 7, a minus 9. And now we need to substitute back in what a is. This is the cube root of x plus 9, because a is the cube root of x, times the cube root of x. Oh, this was supposed to be minus 2, I apologize. Minus 2. So here's our final answer. This is factored. You can feel free to skip straight to here if you recognize that this is like, oh, here it is, squared, here's that thing, and so it is just factoring x squared plus 7x minus 18. You don't have to make the substitution, but if you're having trouble seeing it, it can be helpful. All right, let's do this one. This one has two variables in it, and I'm going to start by rewriting this. This is 3 times 1 over x squared. 3 times 1 over x is 3 over x, and 1 over x times 1 over x is 1 over x squared, plus 10 times 1 over x times y, which is 1 over x times 1 over y, plus 3 times 1 over y squared. And so what we'll notice is we have, here's our x squared term. So if we wanted to, we could rewrite this as 3a squared plus, where a is, let a equal 1 over x. We're going to let b equal 1 over y. 10 times a times b plus 3b squared. So it's tricky sometimes to see that this is a quadratic squared, but it is. Here's our quadratic being squared, and we can now see it's one of those ones that has two variables. And the way we do this is we basically like ignore the b's and factor it like it was 3a squared plus 10a plus 3. It'll just have b's on the end because we need to get the b squared. So this is one of those ones where a is not equal to 1, so we need to do factoring by grouping. 3 times 3 is, it's going to be 9, and they need to add up to be 10. So the two numbers that do that is 9 and 1. So I'm going to rewrite this as 3a squared plus 9ab plus 1ab plus 3b squared. And then we factor out the common factor here. 3a times a plus 3b plus, these have a common factor of b, times a plus 3b. And then they both have a common factor of a plus 3b. So it's a plus 3b times 3a plus b. That is my final factored form. But I made a substitution, so I need to substitute that back in. A was 1 over x. So this is 1 over x plus 3 times b. 3 times 1 over y is 3 over y. 3 times a is 3 over x. and b is 1 over y. So this is that factored. All right. I guess if I wanted to, I could combine these fractions into a single fraction by getting a common denominator. This is kind of an advanced thing, but we could multiply by x over x here and y over y. This is, you did not need to do this if you didn't see it, but it is a nice advanced trick. And so you get y plus 3x over xy times 3y plus x over xy. That's another way to write this answer with the combined into a common denominator. All right. Let's see. Any other ones we want to do? Let's do 18. This one's a little bit weird. There's an x squared, there's another x squared, there's a 9a, there's another minus 9. There are two ways to do this. The first way is we just group them together. I don't see any way to factor this whole thing, but we can factor them into pairs, and I'll show you two ways to do it. The first is these both have an a in common. So it's a times x squared minus 9. These both have a b in common. So b times x squared minus 9. And now that they both have an x squared minus 9 in common, this is x squared minus 9 times a plus b. And then this can be broken up even more because it's a difference of two squares, x plus 3, x minus 3 times a plus b. So that's fully factored. Or maybe you noticed, I'm going to rewrite this here. Maybe you noticed that there were two x squared ones, and there were two ones with 9. So I'm going to rewrite this as ax squared plus bx squared minus 9a minus 9b. And so now I notice these both have an x squared in them. So it's going to be x squared times a plus b. These both have a negative 9 in common. Minus 9 times a plus b. And now these have an a plus b in common. So it's a plus b times x squared minus 9. And again, I can factor this more. X plus 3 times x minus 3. Either one of these techniques gets you to the same answer. I hope that at least gives you a start on your homework. I hope you can treat these like puzzles where you have to figure out kind of what type of thing it is, how to rewrite it, what you're allowed to do and what you're not allowed to do. I think they should be quite fun if you view them as puzzles. I will tell you, this is one of the few times where I think it is completely appropriate, if you get stuck on one, to use an online solver to help you understand the steps. So if you go to like mathway.com or something like that, there's other ones, Photomath, there's a bunch of them. They can walk you through. If you get stuck on one, you really want to be able to do these all on your own. But if you get stuck on one, you can use an online solver to help you, but make sure you understand what they're doing at each step and why. And if you don't understand, don't write it down. If you write down a step you don't understand, that's not you doing your homework. If you're using them to solve it all for you, that's not you doing your homework, and your quiz on this after spring break will go very badly. So you want to be able to do all of these yourself, but if you need to get some help on being able to do it by yourself, that's fine. That's what things like this video and using tools like this can be used for completely appropriately. Good luck on the rest of your homework.